Hi, my name is Jeff, and thanks so much for checking out my videos. And if you have subscribed, I really appreciate it. I uploaded a general builder video of this small tube amp some time ago, and I had a heap of requests asking for more detailed information on how the amp was built. That is what this video series is all about, a step-by-step practical approach to building a small tube amp using this powerful little amp as an example. Now, just a quick overview of the amp. It has two channels, clean and crunch, switchable at the amp, the clean channel having 2 gain stages and the crunch channel 3. And to keep the signal as unmolested as possible, there is no tone circuit. However, there is a switch which tightens up the tone considerably when you want to crank up the gain without muddying up the bass. Follow the link here for the best demonstration of this amp. You may have already built a kit set amp, and just like the position I was in, you were none the wiser as to what in the heck was going on. Tube amp circuits are confusing at the best of times, and the aim of this series is not only to build a pretty decent little amp, but also figure out exactly how everything works. Additionally, the goal is to put you in the position where you can begin to design your own amp, and at the very least know which components to modify to develop your own tone in whatever tube amp you have. In order to do that, there is going to have to be a little bit of theory, but I want to keep it as simple as I can and really try to unravel the mysteries of the tube amp in the most unconfusing way possible. We will cross each theoretical bridge as we come to it. To aid in the build process, you can visit my webpage. The link is in the description below, and download the full plans for this amp that include the schematic, the layout diagram, whether 120 volt or 240 volts, chassis layout, parts list and codes. It's all in there. I tried to make it free for all you YouTubers, however the constraints of the website would not allow me to do so, so you can download the plan pack for $1. This first video is an introduction, and I just want to go over some tools and types of components that I specifically use that I think are essential. If you have always wanted to build and potentially design your own tube amp, then this is the series for you. So feed the cat, water the tomatoes, and fire up your dusty old soldering iron. You will require a soldering iron, and something like this is all you need, really. This is a fairly cheap Hakko, H-A-K-K-O, and it's a 60 watt version with a fairly pointy tip on it, and that's really all you're going to need for a project like this. Some kind of multimeter is what you really need, and when you're checking continuity, that kind of thing inside the tube amp, you really need a multimeter to see what's going on. And also, if I could make one suggestion, it would be to either make yourself or buy yourself an extra set of leads that have alligator clips on them. Not only for safety, but also for ease of use. It's just invaluable when you're inside an amp. You can just put the alligator clip on a component and get hands-free, and just so handy. A hot air gun is something that you are going to need, and that's for the heat shrink tubing. Heat shrink tubing is just awesome. You're going to need some of these. Definitely the color coded, just to color code your wires when you're doing switching. It's just invaluable. So get as many colors as you can, and the sizes that you're going to need are 332 inch. That's a handy size. Get some of that. Get some 1/8 inch. You can get any color of that. Also, you might need some bigger stuff for insulating some of the big AC inlets, and that's 3/4 inch, and also some 1/16 inch heat shrink tubing for the leads of components like resistors, and again, just invaluable stuff. And get the polyolefin make sure that you get polyolefin heat shrink. Don't get the other stuff because it's plasticky and it's got a horrible finish to it. Polyolefin is really nice and rubbery, so get that stuff. On the subject of wire, I mostly use solid core wire, and for the sole reason that you can bend it and it'll stay where you bend it, and I find that really handy. The only drawback is if you bend it too much, it will snap, and that's a real bummer when that happens. It's happened to me, and that normally happens on the earth wire that I use. So for that reason, I use a stranded wire for the ground or the return circuit, and we'll go over that in a bit more detail when we get to it. But for the most part, I use solid core wire. These are the tube sockets to use, the 9-pin tube sockets. I really like Belton just because they resist a bit more heat. And take note of the mounting configuration here. And these are mounted from the underside of the chassis, and that's really, really important. Extremely important. So buy the 9-pin tube sockets that you can mount from underneath the chassis. Onto the subject of capacitors, and there's a lot of conjecture about capacitors. Is there a difference between capacitors? Yes, there is, and I know that because I've done my own experiments on it. You can check out my videos if you care to check that out for yourself. There definitely is a difference in tone, and not great difference, but there certainly is. And there's a whole range of capacitors you can get. These ones are mid-range, so they're about $3, $4, $5 each US, and they've got a really good note separation, and I really like them, and they're the ones that I use. You can go cheaper. They're in the $1 sort of dollar below range, and you can use them if you want, and that's fine. And you can certainly go more expensive into the sort of hi-fi realm. I wouldn't really recommend that you use them for a tube amp because they're a bit wasted when you're playing with distortion and whatnot. But I really do suggest these are very, very good. And also you'll notice that they've got very long leads, which is fantastic when you're building a tube amp. Long leads on any component are just great. For the electrolytic capacitors, and they're used for the filtering, and don't worry about terminology at this stage, we'll cover that when the time comes, but I prefer to use both F&T and Sprague electrolytics, and these have the axial leads just like in resistors and the film capacitors, and I much prefer this configuration than this type of capacitor, which is commonly called a can capacitor, which has 2 or 3 capacitors in one, and it's normally mounted on the chassis, and I don't really like them because you have to run long leads to them, and whereas with the axial capacitors you can lay them on the turret board, and it's just a lot neater. Moving on to potentiometers, and you can see you can get a whole range, and you can use whatever potentiometer you like. Just be sure to know exactly what you're ordering. I know I've ordered these in the past thinking that they're going to have the alloy stem, but they've come in the nylon stem, and although they work, they're not my favorite. You can cut them pretty easily. This one is an Alpha brand, and it's really, really good for the price. I've had some Alphas on amps that are just no noise whatsoever after a long time. I really recommend these ones. And also Burns, this variety is a sealed variety, and it's going to cost you 3, 4, 5 times as much as these guys. Certainly nice to use, that's for sure, but it's totally up to you and your preference on this one. When it comes to resistors, is there a difference in resistors? I really don't know. If there is, it's negligible, and I have to be honest and to tell you that the only reason I use these is because I've got really long leads, and I love the color red, and they look cool. But they're a whole different variety. You can get carbon resistors, carbon composite they're called. These ones are metal film. You can get carbon films, I believe, as well. So you can get a whole range, and they range in price as well. But to be honest, I don't think there's going to be much difference in any resistor you use, and I just like these ones for the color and the long leads. And you will need some hardware to fix the tube sockets and also the transformers to the chassis. And I really like this arrangement on this nut. They're called Kep lock nuts, and they've got the little locking mechanism attached, and they really stay on well. And I do recommend them if you're going to be doing a bit of amp building. Just going to save you a heck of a lot of time and frustration. This is the recommended chassis to use for this project. It's a Hammond aluminium chassis, 10" by 6" by 2" made in Canada. You can get them pretty easy online, and this is really well priced. Another tool that I would call essential is some kind of wire stripper. Something like this is going to come in very handy when you're stripping the insulation off wire, or if you have to go into the chassis, if you need to do any repairs to the wire or do something in the chassis, something like this, you can get in there and reach, and it's going to be very, very handy indeed. You can get away with a knife if you're really, really skillful, but something like this is going to make life a heck of a lot easier for you. This is one tool that I would consider essential. It's a real fine set of pliers, or tweezers, I guess you could call them. Also this kind, if you've got a real sort of good set of fine nosed pliers like this, going to come in really handy when you've got to get in close right into the circuit when you're trying to grab that little bit of wire or little component. These you really must have. For today's theory, there's only one thing to learn, and that is with alternating current and direct current. Specifically with alternating current, the charge starts to go positive, and then it goes negative, and then it goes positive again, and it traces out this sine wave pattern. And that pattern is demonstrated the most easily from your guitar signal as the guitar string passes over the pickup magnet, goes back and forth, back and forth, back and forth, and it traces out a sine wave. And depending on the frequency, if it's a high E, then the sine wave is going to be quite close together. If it's a low E, then the sine wave is going to be further apart. And that crisscrossing of the guitar string over the magnet is picked up by the pickup coil, and that is transferred through all the wires, through the guitar, and then on to the tube amp. And also the mains supply that comes from the wall of your house, when you plug it into your tube amp, that is alternating current. And contrast that with direct current, is just what it says. It's just a direct current, just a flat straight current, and that's used to power the tubes or operate the tubes. And as you can see, we've got both these currents in the tube amp, and in some specific examples we've got both alternating current and direct current existing in the same wires at the same time. You don't really have to know why that occurs at the moment, just that it does. Get that concept well and truly embedded in the brain, and we'll move on to some more theory next time. And just to wrap up this introductory video, I do encourage you to head over to the website and download the full information pack. There's everything that you need in there to follow along closely with the build process, the tools that you require, full parts list, the source of where I got my parts from. Also keep an eye out on the website in the project section for full information about the theory slides that I'm using in this video series. And I thank you again for tuning into any of my videos and subscribing. I really, really do appreciate it. And I hope that you'll end up with a really cool little powerful amp at the end of the series. And I'll catch you next time.